but I wanted to do a couple of these with you, all right? Because they're not easy. That's why we're doing some more practice, even though technically we're done with Chapter 5, but these objectives usually prove to be the hard ones, okay? Some of you have a good start, so I'm going to jump down to this lower part so I don't do something, well, I might for some of you, but I'll try to not do something you've already done, okay? I'm going to do number 6, all right? So number 6, we'll go ahead and subtract 2 from both sides. So we get 3 sine of theta equals negative 2.5. Divide by 3. So I get the sine of theta equals negative 2.5 over 3, which is probably not going to be a very nice decimal, but about 0.83 repeating, or the fraction 5/6, okay? And then I take the inverse sine of both sides. And we end up with 0.985. Okay. I didn't get a negative. That's true. He's saying that this would be a negative right here. Inverse sine of negative 5/6. Okay. Yes, thank you. It should be a negative. All right. So a couple of things are problematic about that. One is that it's not between 0 and 2 pi, so we're going to have to think about that. All right. Again, there's probably ways to rename it. And that's where the drawing the unit circle comes in. Okay. So I know that this is 0, and this is negative pi over 2. So negative 0.985, we'll say, would be right here. Okay. Negative 0.985. All right. Now, again, that's not between 0 and 2 pi, so we want to come up with another name for it. We want the positive name for it, not the negative name. All right. So let's figure out what the positive name of that angle would be. Multiply. All right, so did you get 5.3, we'll call it? Okay. And that is between 0 and 2 pi. But like we've come accustomed to knowing, that's probably not the only one. Okay. Now, sine, if we think about sine, again, this would be my negative 0.83. My picture's a little crowded, sorry. Okay. And the sine is also negative over here. Okay. This could be negative 0.83 because sine's my y-coordinate. All right. So now we want to name this angle, the purple angle, all right, from here to here. So see if you can figure out what would be the name of the purple angle. So 4.13, we'll say. All right. Again, I always think, okay, here's pi, and then if I add that angle, remember you're adding the angle, not the sine. You're adding the 0.985. Okay. That gives me 4.13. Now we know from what a sine wave looks like that one of these is an up wave equation and one of these is a down wave equation. So these are my only answers for part A. Right here, okay? But when it says B, over the set of all real numbers, all right, that's when we have to add whatever's appropriate, okay? So we're going to take one of these, 5.3. Do we know without figuring it out what the period of the sine function is? Just the plain old sine function, plain old cosine. What's the period of those waves? 2 pi. So plus 2 pi n. Right. Because again, all of the ones I ask you to do by hand, I'm never going to alter that. So it's going to be, whether it's sine or cosine, it'll be 2 pi. If it's tangent, it'll be pi. And then that would be, again, either our up wave or down wave, so we need the other one. 4.13 plus 2 pi n. Okay. So specific solutions, general solutions. Let's go on and do a tangent one. Okay, tangent ones can seem very different, but they can be similar. Let's see, add 5. Divide by 3. How are we going to get rid of that tangent? Inverse tangent. All right, still in radian mode because, again, our domain was from 0 to 2 pi. All right. And we get 1.03. Now, you know, when I do sine or cosine, I can make my little, okay, the sine was negative 0.83. I can draw that. If the cosine, I do the over thing. But tangent's a little bit stranger in terms of figuring out how to at least draw the 5/3, because remember, tangent is sine over cosine. So when I draw for the tangent function, I just think about the fact that this is 0. This is pi over 2, or about 1.57. So my angle, 1.03, would be about right there. Okay. So this is my angle, 1.03. Again, I can't really, you know, I suppose I could do, let's see, this is 5. You know, and this is 3. That's a little bit weird, though, because we're on a unit circle. You can't really go over 5. But it's a little bit harder to draw tangent. Again, we can't say it's not the over and it's not the up, like cosine's the over, sine's the up. It's the up over the over. Whoa, there's a lot of... So it's a little harder to draw, okay? Now, this tangent, though, is positive, and there's only one other quadrant where the tangent is positive. Okay, here we got a positive divided by a positive. Decide with the people around you, where's the other quadrant where the tangent is positive? And it is this quadrant, the third quadrant, okay, over here in this area. And our angle would be directly across, a half turn actually, from our other one. Okay. And so if we half turn from this angle, see if you can figure out the name of that other angle. What do you think the name is? 4.17? Okay. Then again, those would be our only answers for part A. Okay. Part B, again, the period of the tangent function is just pi, okay? So we would do 1.03 plus pi n. And really, with the tangent function, you only need one piece, because remember the tangent goes like this, okay? So there's really only an up wave, but most people get in the habit of doing 2 pieces, so you really don't need this piece, but a lot of people, I wouldn't mark you wrong if you wrote it there. A lot of people will put this piece also, because you just kind of get in that habit. But you really only need one piece. Because if you figure out how far these are apart, subtract those for me a minute. 4.17 minus 1.03. How far apart are those? 3.14, which is pi. Okay? So if I added pi to here, I'd get this one. So you really only need one piece. Okay? All right.